Welcome to Full Spectrum Science and the Countdown to Mars. I'm Ron Hipschman, your host for today from the Exploratorium in San Francisco. Tomorrow, the Perseverance rover will be landing on the surface of Mars. And today we thought we would give you a little preview of what's going to happen and a little review of what has happened and what has led up to having this amazing rover on the surface. There are many ways to plan a mission to Mars. The earliest and easiest is to send out a spacecraft to simply fly by the planet, gathering data as it passes. The first to do this successfully was Mariner 4 on November 25, 1964. The spacecraft returned a grand total of 21 photographs covering only 1% of the surface of the planet. Those photos showed us a surface unexpectedly pockmarked with craters, some with frost in them. Data from Mariner 4 came back to Earth at the astonishing rate of 8.5 bits per second, taking 4 days to return the photos from its internal tape deck. Remember that broadband data to your home is typically 25 million bits per second, 3 million times faster. Mariner 4 was also the first spacecraft to navigate by the stars. The second type of Mars mission is putting a spacecraft in orbit around the planet. This has the obvious advantage of extending the observation time tremendously, but with the added difficulty of the orbit insertion maneuver. Mariner 9 was the first truly successful orbiter. Although there were 6 previous attempts to orbit Mars by both the Soviet Union and the United States, Mariner 9 was the first long-term orbiter to return significant data. In 349 days, the spacecraft returned 7,329 photos of Mars, covering 85% of the Martian surface. Among Mariner 9's discovery was a vast canyon stretching 2,500 miles across the planet, almost long enough to cross the entire United States. It was named Valles Marineris after the orbiter. The spacecraft identified about 20 volcanoes, one of which was later named Olympus Mons, towering 85,000 feet above the plane where it sits, with a base diameter of 370 miles, dwarfing all volcanoes on Earth. Here, we compare its size to the state of California. The spacecraft also captured 80 relatively close-up views of the moons Phobos and Deimos. The third type of mission to Mars is to actually land a stationary spacecraft, or lander, on its surface. This was first successfully accomplished twice with the Viking 1 and 2 missions. Viking 1 landed on July 20th, 1976, and was followed shortly by Viking 2 45 days later on September 3rd. Each mission included both a lander and an orbiter. Over 57,000 high-quality photographs were returned from both orbiters and landers combined. This is the first photo ever sent from the Martian surface. Scanned in line by line, it was sent back to Earth and slowly built up this breathtaking image. The Exploratorium had a direct microwave link to NASA Ames Research Center in Mountain View. We watched real time as these Mars images arrived at Earth. Subsequent to that first image, Viking 1 and 2 sent back amazingly detailed panoramas of their environment in stereo and in color. Here's an example of a composite color photo sent back by Viking 2 just 15 minutes before sunset. The Vikings also had a mechanical arm designed to reach out and dig samples from the soil, looking for signs of life. Although no life was found, some very interesting soil chemistry was investigated. The last type of Mars mission is to land a spacecraft that actually moves and explores the surface of Mars, a rover. That's what we're going to be talking about today. Mars, the god of war, has not been kind to Earth's missions to Mars. In fact, as you might expect, he's been quite hostile. Here, I've listed all 60 spacecraft that have been sent to Mars. Of those, in red are 27 failures, or 48%, 3 partial failures, in yellow, or 5%, and 21 successful missions, in green, or only 46%. The U.S. has been fortunate with a 75% success rate. Spacecraft sent to Mars have come in all shapes and sizes. The landers and rovers are seen at the bottom. These are the 3 successful rover missions sent so far to Mars. Sojourner in 1997, the 2 Mars exploration rovers, Spirit and Opportunity, in 2004, and Curiosity, or the Mars Science Lab, in 2012. As you can see, they get bigger and more sophisticated as time passes. Pathfinder, which landed on July 4th, 1997, introduced a unique airbag-based entry, descent, and landing system that I can't show you, but was the same as the MER rovers, which I will show you in a moment. Its planned mission was for 7 days of operation. It lasted for 85 days. The Pathfinder mission included both an instrumented lander, which you see in this animation on the right. The lander had cameras and a weather station. The small microwave oven-sized rover, named Sojourner, was able to wander the landing site, analyzing the local soil, rocks, and boulders with its alpha proton X-ray spectrometer and cameras. Here's a panorama taken by the lander. A couple of peaks in the distance is possibly a crater rim. Rocks and boulders of all sizes are scattered as far as the eye can see. Sojourner can be seen analyzing a rock named Yogi. Continuing, more rocks and patches of sand come into view, and as we reach the limit of this panorama, you can just see the mast carrying the weather instruments on the right side of the frame. Yogi isn't the only named feature in this labeled panorama. Science fiction characters like Ender and Zaphod appear, as well as a good variety of cartoon personalities: Stimpy, Bam Bam, Boo Boo, Scooby-Doo, Roadrunner. There's even a Pop-Tart rock named for its shape. Sojourner spent 83 days of a planned 7-day mission exploring the Martian terrain. Here, you see its path around Pathfinder lander in an interesting overhead fisheye view. Sojourner traveled a total of 100 meters, or 330 feet. 16,500 images were sent back from the lander and 550 images from the rover. The second successful rovers on Mars were Spirit and Opportunity, the Mars Exploration Rovers, or MER. Yes, this was the official patch for the mission. In case you don't recognize him, that's Marvin the Martian from a favorite Warner Brothers Looney Tunes. Check it out.
Oh, that wasn't a bit nice. You have made me very angry. Very angry indeed.
The MER rovers were a bit larger than Sojourner, about the size of a golf cart, and each carried 9 cameras and a mechanical arm that could analyze Martian soil and rocks with several instruments. There was even a rock grinder called the RAT, or Rock Abrasion Tool, on the arm to help expose the inner, less exposed parts of rocks. As I promised a bit ago, both Pathfinder and the MER rover had a unique way of landing. Let's take a look. First, the aeroshell ejects the cruise stage, which followed it all the way from the Earth. As the aeroshell enters the atmosphere, heat shield forward, it would look like a meteor passing through the atmosphere of Mars. Once it was through, parachute would deploy. This is a supersonic parachute. It was traveling maybe twice the speed of sound at this point. It would slow it down quite a bit. Eventually, they would eject the heat shield and lower down the lander and rover on the end of a long cable. When it reached within a few hundred feet of the surface, airbags would deploy, and retro rockets would further slow down the descent. The cables, the tether was cut, and the rover and lander would bounce many, many times on the surface of Mars until eventually they would come to rest. Once at rest, the airbags would be deflated and reeled in, and the four-sided pyramid would open up. No matter which side it landed on, it could always right itself. The rover folded up inside. Now the job was to unfold. First, the solar panels would stretch their arms. Once the solar panels are deployed, they could put up the mast with the cameras on it and the high-gain antenna, that pie plate-shaped thing in the back. The MER rovers would then take a quick look around, just in case, wanted to get some data. And that would pretty much end its activity for the first day, with the beautiful blue Martian sunset. The next day, time for the rover to stand up and get a little exercise. Stretch out there, yes, stretch those wheels out. Again, do a little camera work. There were 2 color cameras and 2 black and white cameras at the top of that mast. And the end of another day's work. The next day would be an exciting day for the MER rovers because they would actually start their mission and roll off of the lander. They used a unique suspension system called the rocker bogie system, and there are 4 wheels that can steer here. Rather than watching an animation of the rover moving around, let's watch the real thing. This was taken from the left front navigational camera of Opportunity. The sound you hear is an indication of the roughness of the terrain. On the right, you see a map with Opportunity's track. As mentioned, there were 2 of these rovers. Spirit landed on January 4th, 2004. The primary mission for both rovers was to last 90 Martian days. That's the warranty. Spirit lasted 2,266 days, during which it traveled 4.8 miles and took 128,000 pictures. Opportunity, which we're looking at now, landed 21 days after Spirit on January 25th, 2004, and lasted an incredible 5,352 Martian days, or 5,498 Earth days, just over 15 years. Not bad for a 90-day initial mission. Opportunity traveled 28.06 miles and took 224,642 pictures, some of which have been made into the movie we're watching. Both rovers lasted far longer than their warranted 90 days. The latest rover mission on Mars is Curiosity, also called the Mars Science Laboratory. If you thought that the entry, descent, and landing of the Mir rovers and Pathfinder was wacky and audacious, both Curiosity and Perseverance take it to a whole new level. But we'll only watch Perseverance, since they're very similar. It starts the same as Pathfinder, or the Mirs, by jettisoning the cruise stage. But no, I said I'd show you that when we get to Perseverance, so let's just move on. This is the Curiosity engineering model, which we visited at JPL. As you can see, it's much more complex than any previous rover, with 10 scientific instruments, some mounted on a mechanical arm with a 7-foot reach. The Curiosity rover is the size of a minivan. Unlike the Mir rovers, with a 90 Martian day mission, Curiosity was designed to last for one complete Martian year of 668 sols, or 688 Earth days. It landed on August 6, 2012, and has been in operation for 3,111 sols as of February 17, 2021, almost 5 times the primary mission, and still going strong. As of January 12, 2020, Sol 2995, Curiosity has driven 14.83 miles, and it sent back almost 500,000 pictures. Curiosity has shown us dark dunes, layered rocks that must have been made in the presence of water at some distant point in the past. As Curiosity climbs Mount Sharp, here seen in 2015, it's exploring the geological past of Mars as it ascends up through younger and younger layers of rock, telling us some of the history of the planet. And of course, there are those beautiful blue Martian sunsets. As a quick aside, although Curiosity does have some autonomous driving capability, it's still under the delayed control of drivers on Earth who must practice their driving skills. On our visit to JPL, we had a peek at the Mars Yard, where driving and maneuverability tests are performed. Here, the test bed drive section of the rover is driven over different types of terrain at different slopes. This rover contains only the drive section of the real rover, not all of the scientific experiments or the fancy computer stuff inside. This rover is called Scarecrow because it doesn't have a brain. Get it? I asked the operators if they would drive Scarecrow over a boulder so we could observe that rocker bogie suspension. They let me choose a surprisingly large rock and then drove over it. Notice that even though a wheel must leave the ground to drive over the boulder, the other 5 wheels are still flat on the ground, providing the greatest traction. All rovers sent to Mars so far have employed this clever invention. Let's just watch as it drives over that boulder now. See, all 5 wheels, other than the one on the boulder, are still on the ground. By the way, the wheels have those holes in them which spell out in Morse code, JPL. They got away with sending that to Mars, and the Curiosity rover has been labeling Mars with JPL ever since. They didn't get away with it on Perseverance. No Morse code on Perseverance's wheels. This is, by the way, the rover driving at full speed. Pedal to the metal. Having rovers on campus down there leads to some interesting caution signs at JPL. Which leads us to the current mission, Mars 2020. Mars 2020, renamed Perseverance, was launched in July 2020 and will be landing February 18th, 2021. Like Curiosity, its mission duration is at least 1 Martian year. It began its journey July 30th, 2020 from Cape Canaveral. It took 203 days to arrive at Mars, performing 6 target correction maneuvers, or TCMs, to keep it on track. Perseverance's target is Jazero crater, which has a pretty equatorial location right there on the globe of Mars. You can also see the landing spots of NASA's other successful missions on our slide, but let's look closer at Jazero crater. Jazero crater was formerly filled with water, forming a large lake, about the size of Lake Tahoe. This photo is colored to emphasize the height of the terrain. Lighter green and yellow colors are higher, and the darker blue colors are lower. The black ellipse marks where Perseverance will be landing. The lake has a large inflow channel and a large outflow channel. Let's look closer at the inflow to the lake. We see a large delta formed by sediment entering the lake. This is a likely place to find preserved, fossilized microbial life, if any ever existed on Mars. We want Perseverance to land right next to the delta. The spacecraft itself has 5 basic parts. The cruise stage, which accompanies the spacecraft to Mars and provides guidance and power. The rover and its descent stage are encased between the back shell and the heat shield that provides protection during its fiery descent through the thin Martian atmosphere. Just to get you prepared, here's the entry, descent, and landing, or EDL, sequence. Perhaps the best way to see these is in action during the entry, descent, and landing procedure, which NASA calls the 7 minutes of terror, at least for the mission operators. This technology was the same as used for Curiosity. As we look around, eventually, this is February 18th, 2021, we'll see the aeroshell and cruise stage come at us and past us. About 10 minutes before it hits the atmosphere, it'll eject the cruise stage. It uses active navigation. As it enters the atmosphere, the heat shield pointed forward will keep the heat from penetrating inside where the lander and descent stage are located, looking like a fiery meteor crossing the Martian sky. The heat shield allowing the heat to move away. It's quite a rocky ride inside. You have to test and shake the lander, make sure it'll survive this before it takes off. There's Jazero crater in front. After about 1 minute and 20 seconds, the parachute will deploy about 2 minutes after entry. And in about 4 minutes after entry, the heat shield will separate from the aeroshell. That will happen in just a moment here. There it goes. It'll look down. The cruise stage is then, with the lander, the descent stage is then released and performs a powered descent. It acquires the ground with radar and cameras, and at about 70 feet above the ground, there's the delta. We're flying just past the delta there. When it gets to about 70 feet above the ground, it will lower the rover from the descent stage on a tether, and then it will softly set it down and explosively detach the cables, and the descent stage will then fly away to land, not so gently, a good distance away. And this will leave our nice little rover on the surface of Mars, not set up yet. In the next successive days, it'll put up its camera mast and deploy several other instrumentation packages on the rover. The mission of Perseverance is to search for signs of past microbial life and to examine the geology and the weather on Mars. There's a complete weather station. It's those two things sticking out from the camera mast there. The rover has a drill on its arm that can collect core samples of the most promising rocks and soils. It's an extremely complicated and versatile roving laboratory on Mars. Perseverance carries carefully calibrated samples of material for its instruments to use to make sure its measurements are correct. In the top middle of this array is a slice of a meteorite scientists have determined originally came from Mars. We have a sample of a Martian meteorite right here. Here it is. Underneath this hemispherical lens is a thin slice of Martian meteorite, and I can actually reach in and touch it with my hand. It's pretty amazing to be able to touch something that came from another planet. Isn't that cool? Perseverance has a set of unique tools. The camera on the mast also has the ability to send out vaporizing laser pulses to analyze rocks and soil. This helps determine which rocks scientists should have a closer look at. At the end of the arm is a drill that can take a core sample of solid rock. Here we are reaching out to an interesting rock, putting the drill down, and now it's going to drill down into the surface of Mars. This is actually more than a drill. It takes an actual core sample. That core sample remains inside the drill. The core sample is brought back to the rover for careful examination and goes through a whole series of manipulations. An extremely complicated mechanism was built into the rover to handle these samples. The rover will be able to drill about 40 separate samples. Key steps will be to measure the volume of the sample. It's going to seal that sample tube. It's going to image everything it does, and then it's going to move that tube to storage. Again, it's going to store about 40 of these sample tubes. The tubes themselves have been cleaned to ultra clean. We don't want to bring any biology to Mars with us, so these are ultra sterilized. The collected core samples will be left on the surface of Mars for a future mission to collect and return to Earth. The idea here is that the rover will visit various places and then come back and deposit all the samples at a collection point. The future Mars sample return mission will dispatch a small rover to go out and collect the samples that were left behind by Perseverance. It will collect all these samples and return them to a waiting lander. And you can see here it has a small mechanical arm that can pick the samples up and put them in a little storage area. This is a solar-powered rover, as opposed to Perseverance, which is nuclear-powered. These have really interesting wire mesh wheels, as opposed to the solid aluminum wheels that we saw before. Here, you see both the rover and the lander. The rover will retrieve the sample tubes, and the lander will repackage them for their return flight. Well, it's sitting here on the surface, and here's the package it puts it in. How does this package return? Well, that lander has built into it a small rocket, a very small rocket. And that package of samples will be put into that small rocket and launched from the surface of Mars. It will rendezvous with an orbiter that is in orbit around Mars. The small rocket will open up. The small package of samples will rendezvous with an orbiter. It's a very complicated orbiter. Inside the orbiter, the samples will be captured, they'll be repackaged, and that new package will be put into an aeroshell, which is also has to be assembled inside the orbiter. There it is, now it's fully assembled. That orbiter will fire its engines and return to Earth. Now, the entire lander is not going to go through our atmosphere. It's going to take several months to get back, but when it arrives at Earth, the aeroshell with its precious cargo will be released. That aeroshell with its heat shield will then enter the Earth's atmosphere for a spectacular descent and hopefully safe landing. Lastly, Mars 2020 Perseverance carries an interesting passenger. Attached to the underbelly of the rover is a helicopter designed to fly in the very thin atmosphere of Mars. This helicopter, named Ingenuity, carries no scientific payload, only a couple of cameras. Perseverance will deposit Ingenuity on the surface and back away a good distance. Test both propellers. There's two propellers, they counterspin. Perseverance will use its cameras to observe the flight of Ingenuity. Data is sent back to the rover, which will then relay the data to an orbiter and then to Earth. Ingenuity is a technology demonstration. NASA believes it might be useful on future missions to provide forward scouting and reconnaissance, or the ability to do some science in a place inaccessible to a rover. That's a noisy helicopter. Ingenuity should be very useful should we have future human missions to the Red Planet. Ingenuity is an autonomous vehicle. It can fly wherever it needs to, but it must fly back and be close to the rover because it has to send its data back to the rover. Ingenuity has solar cells on top so it can recharge its batteries in the somewhat weak Martian sunlight. Thank you for spending time with us as we count down to Mars. Join us tomorrow as we follow Perseverance as it lands on Mars in real time. This has been Full Spectrum Science with me, your host, Ron Hipschman, from the Exploratorium in San Francisco. We know that times like this are difficult, but if you can, help us keep content like this free and accessible to all by donating today at www.exploratorium.edu/connect. Thank you. We'd like to thank NASA, our partner in this webcast, for inspiring us and supporting this program.